So who has had problems getting fly ash this year? Okay, a couple of people. I thought it'd be a little bit more, but crowd's a little sparse. So they asked me to talk about fly ash supply and kind of I wanted to kind of give a big picture of fly ash supply and where is it going, I guess. So again, just my outline presentation. I'm not going to go over that. All right, so just real basic. Everyone knows where fly ash comes from, right? Coal burning power plants. Get the coal, put it in the furnace. All the ash that falls to the bottom of the furnace, called bottom ash. All the ash that flies up with the exhaust gas is fly ash. Clever nomenclature, but that's how they got it. Pass it through precipitators, gets collected either through electrostatic or bag houses, and then funneled down to hoppers, and then out to your silo or disposal, whatever the plant's going to do with that particular material. If you've never seen fly ash up close, this is it. A bunch of round, spherical shapes. Chemistry and shape of fly ash does amazing things for concrete, and that's why we love it. Okay, we want fly ash. We want to try to get fly ash in every cubic yard of concrete we can. It's amazing what fly ash does, and we want to try to promote the usage. However, these supply issues kind of get in the way, and so we have to kind of deal with them as we go. All right, so why do we use fly ash? And I think what I should have put here is why do we specify fly ash? There's a lot of reasons we would want to use fly ash, but there's really a primary reason that our specifications have fly ash in them. And the big one is this. Prior to 1999, fly ash was used just as a cost reduction measure in concrete pavement. During the late 80s and in the mid 90s, we were discovering that a massive ASR situation going on in both cast in place and precast concrete. And here's a couple of pictures. Cast in place barrier, severely cracked just due to the ASR, as barrier has never been impacted. It's just ASR, just a chunk of concrete sitting there in the weather, and it's expanding. Then we have a pre-stressed girder where a crack's big enough, we were able to stick a blackberry into that crack. So that tells you how substantial the expansion is going on in those pre-stressed girders. So this was kind of our main concern. All right, so now we look at all our reactive aggregate in the state. This is the fine aggregate reactivity of the majority of the aggregates back a few years ago. And you can see this 0.1 limit is the limit where things are considered potentially reactive. So from 0.1 to 0.2, potentially reactive. 0.2 and greater, reactive. So yeah, we have a few that are potential, but then man, look at what we got here. Everything else is reactive. So almost 80% of the sands above 0.2. So we know all the sands in Texas are really reactive. So we do have this ASR concern. All right, so in 99, TxDOT issued its first ASR specification, and fly ash was one of the options. And Class F fly ash, I should say, was the main option to use to mitigate ASR. Again, so Class F fly ash is great at mitigating ASR at relatively low dosages. Class C fly ash, however, not as efficient. You could do it, but it takes a lot of Class C fly ash to get you there. If anyone's ever curious of where that 20% limit in the specification came from, here's some test data here showing that 0.1 expansion limit, and then 20% of our F fly ash is in Texas, and that's what we get. So that's where that 20% limit comes from. All right, let's see. All right, so again, I mentioned our main purpose for fly ash is premature deterioration mitigation. Okay, so we have ASR, DEF, sulfate resistant concrete. All those are premature deterioration that we're trying to stop with fly ash. And really, we rely heavily on fly ash for these. There's really nothing else available in Texas that gets us there but fly ash. When we spec high performance concrete, again, typically northern portion of the state where de-icing salts, things like that are being used, coastal, marine environments, where we want really good concrete in terms of durability, not in terms of strength. So fly ash is really what we lean to for that aspect. Again, options 1 through 4 all have some type of SEM in them. However, fly ash is really the only option. We don't have metakaolin, slag, or anything like that in Texas. A little bit of silica fume used in Amarillo, Um, but that's a whole different story. I won't get into that. And then the big thing is permeability, especially with the state or more districts going to brine solutions and more aggressive de-icers or anti-icers. This is a real important thing to take into consider, that you really want high performance concrete to have fly ash, so that way you have that low permeability. And so when you start using these brine solutions, or if you're currently using it on new structures, you're not going to have corrosion issue concerns. So that's one thing to kind of keep in mind. Mass placements, we use it a lot in mass placements to reduce the peak temperature. Again, the idea is taking some of that cement out, replacing with fly ash that doesn't really generate that much heat. And so we could lower that peak temperature and not worry about DEF and things like that. All right, so how much fly ash do we actually use in Texas? So this is just a plot of all the cubic yards of Texas that we consume a year. And so we had a lot going on early 2000s, mid 2000s, and we kind of have this decline here. This data does not reflect the design build projects, and so some of these may be a little higher. But you see, for the most part, concrete pavement is the bulk of our concrete production or consumption in Texas. And so it's kind of difficult to really answer this question because we don't track how much cement, how much fly ash we use. We track square yard, square foot, linear foot. So we have to kind of convert it over to square cubic yardage. And so doing that and then making some fairly good assumptions of how much concrete has fly ash, how much fly ash is used, and things like that. I estimate around 150, 200,000 tons of fly ash are used by Texas a year, or TxDOT a year. Now, we are a small market compared to the overall concrete market in Texas. I think we're about 20, 25% in Texas. So, but we use a lot of fly ash. To kind of put things in perspective, it's about a 5-to-1 ratio of how much Class F fly ash produced versus Class C fly ash. So we generally produce about 6 million tons of fly ash, of Class F fly ash, and about 2 million tons of Class C fly ash a year in Texas. Now, not all of that is spec ash. Some of it has to get landfilled because of the way the power plant runs its mine, so that some of it has to get diverted. So not all of that ash is available for use. But a good portion of it is there, and so again, we barely really dent the fly ash usage in Texas. All right, so what affects fly ash supply? Well, it's these plant outages. And so every spring, power plants go through an outage where they have to go in, take apart their units, take apart the grinders, just rework everything and put it all back together. So these could take a couple of weeks to complete an outage to a couple of months, just depending on how much work the plant has to do. And again, they usually happen in the spring when power demands are low. Mild temperatures, don't really have to run your heater or AC, so there's no need for them running their big cold units. They could just run gas units. If the outage is delayed or unusually long, you can have impacts to your projects, just like everyone's seen this year. Monticello plant went down and they had problems getting it back up, and so it was out like 3 weeks longer than they intended, and so then other plants went into outage, and the whole situation just kind of got out of control. Again, seasonal temperatures. If we have mild winters, mild springs, again, there's no need for these power plants to run their coal burning furnaces, so they'll switch to gas. Gas is just enough to give them a couple megawatts of power, and that's all they really need to trickle into the system, and they don't have to do anything else. So if you're not burning coal, you're not getting ash, so bottom line. Alternate fuels, again, I mentioned this again, low natural gas prices here in Texas. In these times of mild temperatures, they don't have to burn coal. They just burn gas, and it's cheap. And so they're still making power, still making money. There you go. You have no ash. The big one that we just can't get around is the limitation on long-term storage. These fly ash marketers don't have very big silos. They probably have 2,000-3,000 ton silos. That'll last them maybe a week. And so they know they're having an outage. They'll stock up as much as they can. But again, that's just going to get them about a week or so. And so there's just not a lot of storage, and they're not going to invest into more storage because they may not have that contract when the contracts are due. So they don't want to put that investment in and then lose out. So there's an issue going on there between the producer, the power producer, and the marketer of how to work out kind of storage things. All right, so what's the future of fly ash? This is probably the most difficult question to ask. In the short term, there's really no indication of fly ash is going away. We're going to have these points throughout the year where we're not going to have fly ash because of the outages, and we're just going to have to work through those. Coal is still the primary source to generate power, so we still think we're going to have ash. Whether it's F or C, that's another topic, but we think ash is going to be around. In the long term, it's really going to depend on these EPA regulations and how the power plants respond to these regulations. If everyone remembers in 2008 when kind of the whole fly ash issue kind of got brought up, this is the Kingston fly ash pond here. It's about 84 acres. This is it after the dike broke here and it went into the Emery River and destroyed a bunch of property, killed a bunch of livestock, major environmental disaster. Fly ash is hazardous. Every EPA went up, they're throwing the book at power plants, and so it became a real issue, such that EPA was going to call fly ash hazardous and have the power plant monitor as such, but still allow for beneficial use. So meaning, if a truck goes left to the pit, it's hazardous. If the truck goes right to the concrete plant, it's good. So that people had a real problem with that. And so the industry say, this stigma of hazardous, it's going to cause too much liability on my part. I'm just going to stop marketing fly ash. I will pond it all. And that's where we really start to worry, because now we lose all fly ash. There is some good news. Years of committee meetings and lobbying, lawsuits, EPA administration changes, basically has boiled down to EPA saying, you know what? We're going to keep everything as is. We're not going to make any changes. States, you're going to monitor the fly ash regulations as we have been doing. So good news is we still got fly ash and we're going. So a few more slides. The one that worries me is this cross-state air pollution rule. This is where emissions in Texas blow east and they affect other states. So this reduction of SOx and NOx from eastern states could force Class F plants to switch to Class C fly ash, or coal that produces Class C fly ash. Then we lose all Class F fly ash. So that's a real concern that we have. So we're keeping an eye on what happens here. This is the immediate future. This is the one that's really going to get us. All right, what are your options? Other mitigation options? Lithium, other SCMs? Well, we don't have other SCMs in Texas, so that's not a viable option. Lithium's expensive, so really the only one is straight cement and lower realkali loading. That's really all we could do. Sulfate resistance, we're taking a step back in our 2014 spec, and we're only requiring type 2 or type 1-2 cements for sulfate resistance, so you don't have to have fly ash in those mixes anymore. Mass placements, fly ash isn't required, so if you get the temperature down by other methods, you could do it. High performance concrete, however, I think with talking to Bridge, I think we're sticking to our guns. This is where we want fly ash. We don't want to really bend on this one. However, Bridge will consider some situations where substructures that aren't over joints can use non-HPC, but that's on a case-by-case basis. You'll have to talk to the Bridge guys on if they want to really go that way. A couple districts have this requirement of using Class F fly ash between October and April in concrete pavement. That's going to be a problem. April, May, and June are our issues with supply of fly ash, so if you have this in your spec for paving, you may want to take a look at that, because that will be an issue from probably here on out. All right, we sent this out a few years ago. This is when switching ash, I know you can't read it, but we could definitely send this out again. But when you're trying to switch fly ash sources from an F to an F or C to F, it's easy, no big deal. However, going from an F to a C or even to a C to a C, we kind of make you run through all this flow table here. So We have real concerns when we're using C-ash. Again, this is purely an ASR mitigation reason. F-ashes, we're not too concerned. You can switch them, and if you want to waive a trial batch, that's fine. So just keep that in mind when we have these supply issues. And that's all I have. I think we have a few minutes for a question. Graham, you were first. So the question was, are the effects of higher limestone replacements in Europe cements not significant? I guess that's what you're. So they have, their specifications aren't trying to be equivalent to anything. They have a specification, and so they have a strength limit, and so if you could do anything to get that strength limit, that's what you do. So 30% gets you that lower, if you're above that lower strength limit, and they realize you're going to have a lower strength potential, so the strength limit is also lower. So their classes of cements they have in Europe are geared towards having those higher limestone replacements in them. Yeah, we're looking at all kinds of durability, permeability, all these durability issues in our research, and they've done the same thing. They actually have this torture test that we call, and it runs. If you pass that test, you're a pretty good cement, and so they run all their cements through that test, and like I said, they've had good success. The 30%, 35% is a little high, but that's what they allow. Normally it's around 20% is what their typical 1L cement in Europe is as well. Herman, you have one? As far as reactivity? Okay, so the question was, have the Europeans having experience with mitigating for ASR, I guess, for reactive aggregates? Yes, they have their issues there, and again, replacing higher limestone limits reduces alkali content because you're reducing clinker, right, which is the carrier of the alkali. So that is known that if you reduce that clinker, you're going to have lower alkali loadings to begin with. So your ASR issue should also be less. Any other questions? So the cost difference between 1Ls and my understanding is a little bit higher because of the extra work you have to go in metering in the limestone and doing all the processing of the limestone that you're going to add to the cement. So it's a little bit higher. But if you look at the synergy you're getting with like Class C fly ash, you could actually back out the amount of cement you're having in there. So in the big picture, you may have a slightly reduced cost of your overall concrete. So your cement price may be a little higher, but your overall concrete price may come down a little. All right, I think that's my time. One more, quick. So the question is, can landfill or ponded ashes be used? There has been research that is looking at that. We are actually going to be looking at reclaimed fly ash here in a new project we're starting. And so the answer is yes, but it really depends on what the plant has done to the ash to put it in the landfill. If they're adding gypsum to class fly ash so it could set, then we may not be able to use that as we would traditionally class that fly ash. So it's going to depend on what the plant did to the fly ash.